So in this video I'm just going to go through the different quality control issues that ClimPACT can help you identify in your input file that you used for ClimPACT. And so this assumes that you've got ClimPACT already installed and running on your computer, and that you've run ClimPACT up to the point where you've produced quality control output. And so before I begin, I just want to make clear what we mean when we say quality control, at least in this context. So when we talk about quality control, we're talking about making sure that the data you have has been accurately recorded. And what this means is making sure that the temperature and the precipitation values that you have in your input file are actually the temperature and precipitation values that occurred on the day. Okay, so this is different to other processes like homogenization, which aim to make sure that the trends in your input data are actually climatic trends and not something anthropogenic or something that's not climatic. Okay, so this video deals with purely with quality control. Okay, so just briefly a little overview. The quality control functionality in ClimPACT was written by Enrique Aguilera and Mark Proholm, and they originally wrote this quality control code for the RClimDex software, which I imagine some users of ClimPACT would be familiar with. And Enrique and Mark were kind enough to let us adapt this quality control code into ClimPACT. So when you run ClimPACT and it produces all of these quality control files, it's going to put all of these files into a QC directory. And this QC directory is going to be wherever your input file into ClimPACT is stored. And so ClimPACT produces a bunch of different QC files in this folder, and these files have information in them that help you to identify potential issues relating to things like rounding biases, unphysical values, for example negative precipitation, unusually large values, so extreme temperature and precipitation values, and this is particularly important since ClimPACT is a program primarily concerned with calculating indices of climate extremes. So we want to make sure that any extreme temperature or precipitation values we have are genuine extremes, and we want to get rid of any erroneous ones. At the same time, we want to make sure that we don't exclude any extreme values that are in fact genuine. ClimPACT also helps you identify runs of the same value that might be suspicious if you have the same values several days in a row. Duplicated dates in your input file, and as well as unusually large changes in temperature between days. So these are the sorts of things that ClimPACT can help you identify. And so it produces a whole bunch of files in the QC folder, and I've listed them here on the side. So it produces 7 PDF files and 9 .csv files, and I'll go through each type of file here and explain what the contents of that file shows you and how you can interpret that. So I'll start with the PDF files, and just to begin, how these files are named firstly is based off your input file name. So in our example we used a station called wonderland.txt, so wonderland.txt was the input that we used into ClimPACT, and so our QC files in the QC directory are named wonderland _ and then they have an appendage based on the sorts of QC issue that ClimPACT is dealing with. So the first type of PDF file ends in plot.pdf, and there are 4 of these files, one for Tmin, for minimum temperature, for maximum temperature, the diurnal temperature range, or the daily temperature range, and precipitation. And all these plots do is simply show the time series of your data. So all they do is plot your data in an XY graph like so. And so this is really the simplest form of quality control that you can do, but something that a lot of people don't do enough, and it's quite an effective form of quality control as well, just looking at your data. So here you can see from our Wonderland station about 1 decade of our minimum temperature, and you can see the annual cycle here. So this is some station in the northern hemisphere. And just by looking at your data you can see the obvious problems, any obvious problems in your file. So for example, you can see problematic months. So these red circles indicate missing values in your file. And so straight away you can see perhaps where there are lots of missing values. So this month here, it seems to be completely missing. You can also see obvious problems in temperature or whatever variable you're looking at. So for example, if you look at this whole time series, perhaps a temperature of 26 degrees doesn't seem that extreme, but actually a value of 26 degrees in the middle of winter, like this value here, does seem pretty extreme. So just looking at the time series of your data can help you see any suspiciously unseasonal values. And down here is just an example of a decade of precipitation. Okay, the next PDF ends in boxes.pdf, and this file shows you some box and whisker plots that help you identify outliers based on the interquartile range statistics. So it shows 4 box and whisker plots like this, one plot for precipitation, one for TX, TN and DTR. So TX is maximum temperature, TN minimum temperature, and the daily temperature range. And so in this file, ClimPACT is identifying outliers in these 4 variables based on the interquartile range. And so what it does is it aggregates all of your input data into calendar months. So here we've got 12 months of the year, and all of the January data, all of the February data, March data, etc. Are aggregated together, and based on the interquartile range, outliers are identified. And for precipitation, a threshold of 5 interquartile ranges away from the 75th percentile is used as the threshold for an outlier. So remember, the interquartile range is the middle 50% of your data. And so how ClimPACT identifies outliers is it counts for precipitation 5 interquartile ranges away from the 75th percentile. And so for example, this circle here, where ClimPACT has identified an outlier, you can count and it's clearly more than 5 interquartile ranges away from the 75th percentile down here. Okay, and so all of these circles are different outliers that ClimPACT has identified. And then the same process occurs for the temperature variables, except for temperature, a threshold of 3 interquartile ranges is used. So any time a particular day in any calendar month is more than 3 interquartile ranges above the 75th percentile, or 3 interquartile ranges below the 25th percentile, then that day will be classified as an outlier. So you can see here for TN, here are 3 days in July, August and September that have been flagged, and you can see all of these days are more than 3 interquartile ranges away from the 25th or below the 25th percentile. And the details for all of these outliers that get circled here are recorded in a .csv file called outliers.csv, and we'll get to that shortly. But so all of these details can be are recorded, so you can go back into your input file to make any necessary changes. Okay, the next PDF is called boxseries.pdf, and this is very similar to the last PDF we saw. Again, it's using the interquartile range to identify outliers, except in this case ClimPACT plots all of your data in a time series and it aggregates data by year. So it uses the interquartile range for each year to identify outliers. And so you can see for precipitation we've got our whole record here, and you can see that for the first year, any day in that year where that is more than 5 interquartile ranges above the 75th percentile is flagged as an outlier, and you can see that there's one day there that's flagged as an outlier. Again, the same for the temperature variables, except a threshold of 3 interquartile ranges is used. Okay, and the benefit of seeing your data in a time series like this is that it just lets you see any problematic years. So for example, in TN here, you can see something's happened to the mean and the spread in the mid-1980s here that also seems to affect the diurnal temperature range. Okay, the last PDF file is called rounding.pdf, and this helps you identify rounding biases in your data. So quite often what happens when temperature or precipitation values are being manually recorded, people have a tendency to round to the nearest whole number or to the nearest 0.5, or sometimes to the nearest 0.4, 0.6, 0.8, etc. And so ClimPACT here just plots a frequency histogram for each of your three input variables: precipitation, maximum temperature, and minimum temperature. And it plots the frequency that each decimal value gets used, all the way from 0.0 to 0.9. And so you can see here for maximum and minimum temperature that the 0.0 and 0.5 decimal values get used far more than the other decimal values. Okay, sort of 3,000 or more compared to 1,000 or less for the other decimal values. And so this is a very obvious fingerprint of a rounding bias. And there's not much you can do to easily fix this, but it is important to note, and it's useful to report back to your home institutions that this sort of bias is occurring. Okay, onto the CSV file. So the first CSV file is called duplicates.csv, and so this just identifies duplicated dates in your ClimPACT input file. So here we have a sample input file for ClimPACT that you should be familiar with, and you can see that there's 2 February 13th and 2 February 17th. So in our duplicates.csv file, these dates get recorded in a list called dates duplicated. And at the top of every CSV file there's just some station metadata that just gets recorded just for good bookkeeping. Okay, the next CSV file is called outliers.csv, and this records the information for each day that's flagged as an outlier in the boxes.pdf file. So remember, this is what boxes.pdf looked like, where we were using the interquartile range to identify outliers. Well, each of these circles, the details for each of these days, gets recorded in this outliers.csv file. And it's recorded in this list, and it's categorized, and it's a bit odd at first, but basically the list under prec up, which is precipitation up, lists any outliers that lie up above the interquartile range for precipitation, so up above the 75th percentile for precipitation. And so if we look at TN, for example, where there were 3 outliers identified, these are listed in TN low. Okay, so these outliers lie below the 25th percentile for these months. If there were outliers here that were above the 75th percentile, then these would be listed under TN up. And I've deleted a whole bunch of rows from this CSV file just to make things a bit more compact. Okay, the next file is tmaxmin.csv, and this just identifies dates where the minimum temperature is greater than the maximum temperature. So here in our sample input file, the minimum temperature I've set for the first few days is 0 degrees, which could be fine, but the maximum temperatures are all negative, okay, which obviously indicates some input problem. And so these dates are listed in the tmaxmin CSV file, so that you can go back into your ClimPACT input file and make an appropriate change. Okay, the next 2 files end in flatline.csv, and there's one for maximum temperature and one for minimum temperature. And these files just flag dates where 4 or more of the same value occur in a row. And so just using the same sample input file from the last slide, you can see where I've got 4 zeros in a row for minimum temperature. This has been flagged as suspicious, and in the flatline.csv you can see the date where this occurs, the value that's repeated, and the number of times it's been repeated. So any time that there's 4 or more of the same value, that gets recorded, because, well, while it's possible that that's happened, it's extremely unlikely that you get exactly the same value 4 days in a row or more. And again, there's one file for TX and one for TN. The next CSV file is toolarge.csv, and this just flags dates where temperature is greater than 50 degrees or precipitation is greater than 200 millimeters. So in this input file I've just put in some large temperatures over 50 degrees and precipitation of 250 millimeters, and you can see that these dates are recorded in the CSV file. So of course these thresholds are just arbitrary thresholds, but the point of this file is to help you vet these particularly extreme values. And again, because ClimPACT primarily focuses on calculating indices of climate extremes, we're interested in these extreme values. But you might be, your weather data might come from a region that frequently experiences precipitation greater than 200 millimeters, for example, like one of the monsoon regions. So you might get a lot of dates flagged where precipitation is greater than 200 millimeters, and you might safely be able to ignore most of these dates or all of them. If you know something about R programming, you can go into ClimPACT and change these thresholds if you would like. Okay, the next two files end in jumps.csv, and there's one for tx and there's one for tn. This just identifies days where the change in temperature is 20 degrees or more. So you can see here for October 31st to November 1st, the minimum temperature changes by exactly 20 degrees, and so that date is flagged as suspicious. And the last file is just nastatistics.csv, and this simply tells you how many missing values you have per variable per year. And so this file is useful to look at in conjunction with the plot.pdfs that we saw back up here. So you can actually see, instead of looking at those red circles for missing values, you can see the number of missing values exactly that each variable has for each year. So you can see in this record that the first few years there are no, or virtually no, precipitation data. Okay, so that's all of the QC issues that ClimPACT can help you identify in your input file. And as you've seen, a lot of these are common sort of common sense issues or simple errors that can occur, but if you haven't done quality control before, I think you'll be quite surprised at the number of these issues that crop up in your data. So I haven't spoken about what to do when you find an error in your input data, and this is rather subjective, but here we've just outlined, I guess, a good generic process to follow, and as you get more experience, you'll probably change this or add new steps to it. But the first thing to do, so before I even begin this, it's important to note if you haven't realized already, ClimPACT doesn't change any of your data. So whatever input file you put into ClimPACT, that's what it's going to use to calculate the indices. The whole point of the quality control information that I've just shown you is so that you can go back into your input file and make appropriate changes. And then it's up to you to, after you've made any changes to your input file, to put that back into ClimPACT and to calculate your indices. So the first step before you make any changes to your input file is to make a copy, to make a backup. Okay, you always want to have the original file, the unquality controlled file, and then your new file that has had corrections made to it. So we highly recommend that just for good record keeping. And so some of the issues that you come across in your data might be obvious. It might be obvious what to do to fix them. For example, if you have a negative precipitation value, that obviously couldn't occur, and you might change that to negative 99.9 in your ClimPACT input file, which is the missing value for ClimPACT. Unless, of course, if the negative precipitation value looks realistic, if you take away the minus sign, then you might choose to keep that precipitation value, except just making it a positive. This is a bit subjective. And so there are other situations that are a lot more uncertain, and it's not very obvious what to do when you come across them. So, for example, if you have a particularly high temperature on a day, but a temperature that's not technically unrealistic, how do you know if that's just an extreme value or an error in your input data? This is where you have to start doing some investigative work. And so we've listed basically some questions here, some steps that you should go through in your head every time you come across an outlier in your data. And so, you really need to investigate a bit. You go back into the records. If you have a high temperature, was there a heat wave occurring in that location during that week? Do nearby stations record similar extremes on that day? Do errors occur on other errors occur on that date? If they do, then maybe all of the information for that date is erroneous. And so here, there's just a list of questions to ask yourself, basically, every time you come across an outlier. And most importantly, when you make a change, you really want to make sure you keep a record of the changes that you're making. And so for that purpose, in the ClimPACT data, in the sample data directory, you should see a Microsoft Excel template just called QC edits template.xls. And this is just a very simple Excel file that has some columns there, but it makes you record what date you're making a particular change, the original values, the new values, and importantly why you made that change. For example, you might know that there was a fault with the temperature, with the thermometer, and so you've removed a particular temperature value for some day. You'd really want to make sure that you keep a record of all of the changes you make to your new ClimPACT input file, because guaranteed 6 months or a year down the track, when you come back to this, you're going to forget why certain changes were made, or even more so for other people who come back or who come along and use your new file, they might want to know why certain changes were made. So it's very important that you make a record of all of your changes. And so this information is based on advice by some people from the UK Met Office. Okay, so that's all I have to say about the QC issues that ClimPACT can help you identify. Good luck.